Muy buenas noches chicos, bienvenidos a la clase. Hoy lo que voy a hacer un poco con ustedes es en esta parte es leer un poco el texto para que se hagan una idea de cómo es la pronunciación de cada una de las palabras. Lo que yo voy a estar leyendo ahora va a estar en el material de presentación de la clase, entonces pueden ir siguiendo de ahí con la vista, la lectura. How gears work. Gears are used in tons of mechanical devices. They do several important jobs, but most important, they provide a gear reduction in motorized equipment. This is key because often a small motor spinning very fast can provide enough power for a device, but not enough torque. For instance, an electric screwdriver has a very large gear reduction because it needs lots of torque to turn screws. But the motor only produces a small amount of torque at a high speed. With a gear reduction, the output speed can be reduced while the torque is increased. Another thing gears do is adjust the direction of rotation. For instance, in the differential between the rear wheels of a car, the power is transmitted by a shaft that runs down the center of the car, and the differential has to turn that power 90 degrees to apply it to the wheels. There are a lot of intricacies in the different type of gears. In this article, we'll learn exactly how the teeth on gears work, and we'll talk about the different types of gears you find in all sorts of mechanical gadgets. Basics. On any gear, the ratio is determined by the distances from the center of the gear to the point of contact. For instance, in a device with two gears, if one gear is twice the diameter of the other, the ratio would be 2 to 1. One of the most primitive types of gears we could look at would be a wheel with wooden pegs sticking out of it. The problem with this type of gear is that the distance from the center of each gear to the point of contact changes as the gears rotate. This means that the gear ratio changes as the gear turns, meaning that the output speed also changes. If you used a gear like this in your car, it would be impossible to maintain a constant speed. You would be accelerating or decelerating constantly. Many modern gears use a special tooth profile called an involute. This profile has the very important property of maintaining a constant speed ratio between the two gears. Like the peg wheel above, the contact point moves, but the shape of the involute gear's tooth compensates for this movement. Now let's take a look at some of the different type of gears. Spur gears. Spur gears are the most common type of gears. They have straight teeth and are mounted on parallel shafts. Sometimes many spur gears are used at once to create very large gear reductions. Spur gears are used in many devices that you can see all over how stuff works, like the electric screwdriver, dancing monster, oscillating sprinkler, wind-up alarm clock, washing machine, and clothes dryer. But you will not find many in your car. This is because the spur gear can be loud. Each time a gear tooth engages a tooth on the other gear, the teeth collide, and this impact makes a noise. It also increases the stress on the gear teeth. To reduce the noise and stress in the gears, most of the gears in your car are helical. Helical gears. The teeth on helical gears are cut at an angle to the face of the gear. When two teeth on a helical gear system engage, the contact starts at one end of the tooth and gradually spreads as the gears rotate until the two teeth are in full engagement. This gradual engagement makes helical gears operate much more smoothly and quietly than spur gears. For this reason, helical gears are used in almost all car transmissions. Because of the angle of the teeth and helical gears, they create a thrust load on the gear when they mesh. Devices that use helical gears have bearings that can support this thrust load. One interesting thing about helical gears is that if the angles of the gear teeth are correct, they can be mounted on perpendicular shafts, adjusting the rotation angle by 90 degrees. Bevel gears. Bevel gears are used when the direction of a shaft's rotation needs to be changed. They are usually mounted on shafts that are 90 degrees apart, but can be designed to work at other angles as well. The teeth on bevel gears can be straight, spiral, or hypoid. Straight bevel gear teeth have the same problem as straight spur gear teeth. As each tooth engages, it impacts the corresponding tooth all at once. Just like with spur gears, the solution to this problem is to curve the gear teeth. These spiral teeth engage just like helical teeth. The contact starts at the end of one gear and progressively spreads across the whole tooth. On straight and spiral bevel gears, the shafts must be perpendicular to each other, but they must also be in the same plane. If you were to extend the two shafts past the gears, they would intersect. The hypoid gear, on the other hand, can engage with the axis in different planes. Worm gears. Worm gears are used when large gear reductions are needed. It is common for worm gears to have reductions of 20 to 1 and even up to 300 to 1 or greater. Many worm gears have an interesting property that no other gear set has. The worm can easily turn the gear, but the gear cannot turn the worm. This is because the angle on the worm is so shallow that when the gear tries to spin it, the friction between the gear and the worm holds the worm in place. This feature is useful for machines such as conveyor systems, in which the locking feature can act as a brake for the conveyor when the motor is not running. One other very interesting usage of worm gears is the torsion differential, which is used on some high-performance cars and trucks. Pinion and rack gears. Rack and pinion gears are used to convert rotation into linear motion. A perfect example of this is the steering system on many cars. The steering wheel rotates a gear which engages the rack. As the gear turns, it slides the rack either to the right or left, depending on which way you turn the wheel. Rack and pinion gears are also used in some scales to turn the dial that displays your weight. Planetary gears. Any planetary gear set has three main components: the sun gear, the planet gears, and the planet gears carrier, and the ring gear. Each of these three components can be input, the output, or can be held stationary. Choosing which piece plays which role determines the gear ratio for the gear set. Let's take a look at a single planetary gear set. One planetary gear set has a ring gear with 72 teeth and a sun gear with 30 teeth. We can get lots of different gear ratios out of this gear set. In the case A, we use the sun as an input, the planet carrier as an output, and we keep the ring stationary. That means that according to the calculation, 1 plus the ring divided by the sun equals a 3.4 to 1 gear ratio. In the case B, we keep the planet carrier as input, the ring as output, and the sun is stationary. The calculation is 1 divided by 1 plus the sun divided by the ring, and that gives us a 0.71 to 1 gear ratio. In the case C, the sun is the input, the ring is the output, and the planet carrier stays stationary. The calculation is based on minus the ring divided by the sun, and we get a gear ratio of minus 2.4 to 1. Notice that the first gear ratio listed is a reduction. The output speed is slower than the input speed. The second one is an overdrive. The output speed is faster than the input speed. The last one is a reduction again, but the output direction is reversed. So, this one set of gears can produce all these different gear ratios without having to engage or disengage any other gears. Lo que estuvimos haciendo un poco acá es leer el texto para que ustedes puedan acostumbrarse a la pronunciación del mismo. El material con el que van a trabajar lo van a encontrar adjunto a la actividad que van a hacer. Como habrán podido ver, en algunas partes del texto aparecen ciertas palabras que están en negrita. La actividad que vamos a realizar durante esta semana va a ser observar cada una de esas palabras que están en negrita y con la ayuda del diccionario Merriam-Webster construir nuestras definiciones de los mismos. Entonces, tienen una fórmula para hacerlo y un ejemplo en el manual que está adjunto. Por favor, lean bien el material y si tienen alguna duda o alguna consulta, escríbanme abajo en los comentarios. También pueden escribir en el grupo de WhatsApp o pueden escribirme al privado. Cuídense, chicos, nos vemos pronto.